Welcome to Chapter 7, Haloalkene. Learning outcome for 7.1a. Draw the structures and classify primary, secondary, and tertiary alkyl halide. Haloalkene contains halogen atoms X bonded to sp3 hybridized carbon atoms. The general formula for a cyclic haloalkene is CnH2n plus 1x. For cyclic haloalkene, CnH2n minus 1x, where X is fluorine, chlorine, bromine, and iodine. Haloalkene also known as alkyl halide. Classification of haloalkenes depends on the classification of carbon that bonds to the halogen. For primary haloalkene, halogen is bonded to methyl group. For example, chloromethane. Primary haloalkene, halogen is bonded to the primary carbon. For example, chloroethane. Secondary haloalkene, halogen is bonded to secondary carbon. For example, 2-bromopropane is secondary haloalkene. Next, tertiary haloalkene, when halogen is bonded to tertiary carbon. For example, 2-iodo-2-methylpropane. Next, learning outcome 7.1b. Name the primary, secondary, and tertiary haloalkene according to the IUPAC nomenclature. Next, IUPAC name for haloalkene. First step, find the longest carbon chain. For this example, we have 7 carbon, so the parent's name is heptane. Okay, next example. So the longest carbon chain also 7 carbon, so the parent's name is heptane. IUPAC nomenclature for alkyl halides follows the basic rule as described in alkene. F for fluoro, Cl for chloro, Br for bromo, and I for iodo. Number pairing chains beginning at the end nearest to the first substituent, whether it is alkyl or halo. For this structure, the longest carbon chain is 7 carbon. So we start numbering from the left because the first substituent at the carbon number 2. So the substituent is 5-bromo, 2,4-dimethyl, and the parent's name is heptane. For IUPAC nomenclature, the substituents are arranged in alphabetical order. So the name for this structure is 5-bromo, 2,4-dimethyl heptane. Halogen exactly like alkyl for numbering and alphabetical order because the reactivity of halogens and alkyl group are almost similar. For this structure, the longest carbon chain is 6 carbon. So we have 2 substituents, bromo and methyl. So we start numbering from the right because the first substituent is bromo. So the substituent is 2-bromo, 5-methyl, and the parent's name is hexane. So the name for the structure is 2-bromo, 5-methyl hexane. Next, if 2 substituents are present, number carbon in the ring start with the substituent according to the alphabetical order. So the substituent we have 1-ethyl, 2-fluoro, and the parent is cyclopentane. So the IUPAC nomenclature is 1-ethyl, 2-fluorocyclopentane. Next, we have benzene as a parent. So we have 2 substituents, chloro and ethyl. So number carbon in the ring start with the substituent according to the alphabetical order. So the substituent is 1-chloro, 3-ethyl, and the parent's name is benzene. So the name for this structure is 1-chloro, 3-ethyl benzene. Next, We move to the learning outcome 7.1c. Describe haloalkene as compound that contains polar bond and the carbon bearing the halogen is susceptible to nucleophilic attack. Polar CX bond. The electronegative halogen X creates a polar CX bond, making carbon atom electron deficient. So, X is more electronegative than carbon. So, carbon is electrophilic site. The electrophilic carbon of alkyl halide is susceptible to nucleophilic attack.